This lesson is on multiplying powers with the same base. So a power, remember, is a number with an exponent on it, or it could be a variable with an exponent on it. So a to the m, that's a power. And so if you're multiplying two powers and they have the same base value, so in this case, a and a, then you can simplify this by adding the exponents together. So this is defining it algebraically. Let's look at it with numbers. So 4 to the third times 4 to the fifth can be simplified to 4 to the eighth. All right, so all you have to do when you're multiplying powers with the same base is add the exponents. And I can show you why that works. So 4 to the third is 4 times 4 times 4. And then times 4 to the fifth, that would be 5 fours, 2, 3, 4, 5. So you're multiplying 3 fours together and then 5 fours together for a total of 8 fours being multiplied together. All right, this works for negative exponents too. And if you haven't learned about negative exponents, I'll put a link up here with a lesson on that. You should watch that. So b to the seventh times b to the negative fourth, add the exponents, 7 plus negative 4 is b to the third. So let me show you how that works. So remember that b to the negative fourth, we can make it a positive exponent by moving it under the b to the seventh. So this can be simplified to b to the seventh over b to the fourth. Okay, so let's expand that out. So this is 7 b's being multiplied together, 3, 4, 5, 6, 7. And then that's over 4 b's, 1, 2, 3, 4. These b's cancel out, those cancel out, those cancel out, those cancel out, because b over b is just 1. And what are you left with? You're left with b to the third power. So these negative b's are in the denominator and they cancel out 4 of the b's in the numerator. So that's how it works with negative exponents. All right, so let's look at some examples of using this. 12 to the fourth times 12 to the third. So I should have emphasized on the last slide that this only works if they have the same base. So the base value has to be the same. So if this wasn't a 12 here, you couldn't combine these by adding the exponents. So they have the same base, so we just simply add the exponents together. So 4 plus 3, so it simplifies to 12 to the seventh. Easy peasy. All right, negative 5, they both have the same base. So add the exponents, and you get negative 5 to the fifth. All right, that's it. Negative 2 plus 7. All right, so here's where people start to get a little more confused. And what I have to emphasize here is that this 4 is not attached to that z. This 9 is not attached to that z. People tend to think of this as one thing, 4z to the fifth. But it's not. Really, this is 4 separate things being multiplied together. And you can remember in multiplication, the order doesn't matter. 4 times 9 is the same as 9 times 4. That's called the commutative property. So I can easily change the order of this to 4 times 9 times z to the fifth times z to the negative 12th. The 4 and the 9 are not powers. They don't have exponents on them. So they don't really have anything to do with this lesson of adding the exponents. So the 4 and the 9, I can just multiply those together and get 36. And then the z's, I can add the exponents. 5 plus negative 12 is negative 7. And you should never leave your answer with a negative exponent. You should always write it in simplest form, which means that you need to change this to a positive 7. And the way we do that is by moving it into the denominator. So we leave the 36 alone, and we put the z underneath it, and that becomes z to the positive 7th. All right, so this one is the one that really throws my students off. These parentheses don't mean anything. Parentheses are grouping symbols. And following PEMDAS, parentheses should go first, right? Well, when you just have one operation of multiplication, these parentheses don't do anything. So for instance, let me show you an easy example. So 2 times 2 times 2 times 2. That's equal to 4, 8, 16, right? So what if I put parentheses in here? Let's see if it changes the answer. Well, I would do 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. All right, so it didn't do anything. Well, what if I put the parentheses somewhere else? What if I put the parentheses like this? Okay, well, 2 times 2 is 4, times 2 is 8, 8 times 2 is 16. All right, so these parentheses in this situation are just being used as grouping symbols just for a visual aspect. So it's just, they visually want these to be grouped together, but mathematically they are not grouped together. So I can get rid of these parentheses and I can change the order of this so that I can better explain this to you. So the 2 and the 3, again, those are not attached to the variable after them. It's just a 2 times an a. This is a 3 times an a to the second. And the same thing with the 9 and the 4. So I'm going to pull those out because those are not powers. They do not have exponents on them. And again, the parentheses don't mean anything. So I pulled the 2, the 9, the 3, and the 4 out. Let's put the a's next to each other. So I had the a and the a to the second. And then I'll put the b's next to each other. So all I did was change the order of all of this. And now let's multiply these numbers together. Again, these are not powers. They don't have exponents. So that's 18 times 12, which I can't do in my head, so I'm going to break out my calculator. It's 216. The a's, remember there's an exponent of 1 on that a that's not written. So a to the first times a to the second is a to the third. There's 3 a's being multiplied together here. And then here you got 4 b's times 2 b's, so that's going to be b to the sixth. And that would be your simplified answer. You might want to back up and watch that again. All right, so let's see how we can use this with scientific notation. This is all multiplication. So the same thing that I just said in the last problem applies here. These parentheses don't do anything. The parentheses are just grouping this so that you can see this is a number in scientific notation times another number in scientific notation. But I can rewrite this as 3 times 5 times 10 to the 5th times 10 to the negative 12th. That's a 1, I promise. Multiply these together, you get 15 times 10. So 5 plus negative 12 is negative 7. Now, in scientific notation, it's okay to have negative exponents. So we're not going to put this under the 15 because this is scientific notation. But the other rule in scientific notation is this number here has to be greater than or equal to 1 and less than 10. So right now, this is too big. So the decimal point's here. I need to move it back here. So when the decimal point is here, this 10 to the negative 7 is saying move it backwards 7 places. So if I rewrite this as 1.5, when the decimal point was here, it needed to go 7 places. I moved it 1 place, so now it only needs to go 6 places. So this would be 10 to the negative 6th. So let's look at another one of those. So I can multiply the 7 and the 4 to get 28. 10 to the 8th times 10 to the 5th is 10 to the 13th. Again, this is not in scientific notation. But the reason it's not in scientific notation is because this number is too big. It's greater than 10. And again, this number has to be greater than or equal to 1 or less than 10. So right now, this is a positive exponent, so the decimal needs to go 13 places to the right. I need to move it back here to make this proper scientific notation. So when the decimal point was here, it needed to go 13 places to the right. Now I moved it back, so now it needs to go one more place, so now it would be 14 places to the right. So it would be 2.8 times 10 to the 14th. All right, let's look at one more. So 8 times 7 is 56. 10 to the negative 5th times 10 to the negative 3rd is 10 to the negative 8th. The decimal point is here. It needs to go 8 places to the left. I'm going to move the decimal point 1 place to the left. So now, since I've already moved it 1 place, it only has to go 7 places. So it'd be 10 to the negative 7th. There you go. So I hope that was helpful to you. If so, give it a like and a subscribe. And feel free to leave me a comment. Until next time.